Did you know Zeno's dichotomy paradox says motion is impossible? Think of Achilles racing a tortoise. If he always reaches halfway, how can he catch the tortoise? There are endless halfway points. Today, let's look at this interesting paradox. Was Zeno showing limits in our thinking?
Yes, the dichotomy paradox makes us question motion and distance. Zeno amazed the ancient Greeks and started big questions. Aristotle also thought a lot about this and said time and space might be endlessly divided. How do we unite these old ideas with what we know now?
Modern math solves this, at least with numbers. Calculus helps us understand infinite series, which can add up to a set number. Think about a series like 1, 2, 1, 4, 1, 8, which adds up to 1. This shows how an endless process can end in a set result. Does this math beauty show real life?
The paradox remains and asks us to look deeper. Quantum physics adds a twist. The Planck length might be a limit below which physics doesn't work. Maybe distance isn't endlessly divided at the smallest level. Is this where Zeno's thoughts and modern science meet?
With these ideas in mind, I wonder if Zeno's paradox shows our limits more than universal truths. Can finding the set within the endless help us connect what we feel with what is real? Do these paradoxes show where human knowledge can still grow? Did you know that even Albert Einstein was interested in Zeno's paradoxes? He once said they show the problem of matching what we feel about the world to the math that describes it. How do we deal with these problems now in physics?
Einstein had a good point. The dichotomy paradox makes us question space and time. What's interesting is that physics has a way to handle these infinite splits. In relativity, time and space are linked in strange ways, which means infinite points might not fit in quantum areas. But how do quantum mechanics and relativity really solve this?
It's interesting you talk about Einstein, Guy. Modern physics, especially quantum mechanics, shows us how old ideas of space and time stop working. Studies from the Large Hadron Collider show particles don't follow set paths. Could this mean infinite splits, like in Zeno's paradox, don't work in quantum areas? But doesn't this bring us back to the problem of joining quantum mechanics with general relativity?
That's a smart thought, Ryan. In quantum physics, things like superposition and entanglement make our old ideas more complex. The double slit experiment, for example, shows particles acting in odd, almost contradictory ways, going against the idea of steady paths. Do these strange parts mean we are missing a deeper layer that could lead to a unified theory? Or are we still trying to imagine the real nature of space and time?
So, if our understanding of basics like space and motion changes with scientific discovery, what if Zeno's paradox shows the limits of our knowledge? Could these old puzzles be clues to where science is still growing? Could they point to new areas, like joining Einstein's relativity with the unexpected side of quantum mechanics? Here's an interesting idea. A static universe means everything exists in a four-dimensional space-time. It confused scientists and thinkers. This idea doesn't match how we feel time, as if it moves in a straight line. How do paradoxes like Zeno's change how we see time and space? Are they just puzzles, or do they show us missing important truths in physics?
That's a big question, Michelle. The dichotomy paradox makes us think if our idea of motion and time is wrong. Long ago, people like Augustine and Descartes thought time might be just a human idea. Now, some theories say all time exists at once, but we see it in order. Looking at these ideas again might help us understand things like dark matter better.
Guy, talking about the block universe is deep. When we use calculus and infinite series, it shows a clear pattern in what seems confusing. But it's hard to make this math real. GPS uses Einstein's theory for exactness, yet there are limits to this in the universe. Is math just how we see the world, or will a new idea join math with reality perfectly?
Bridging that gap is indeed daunting, Ryan. The strange world of quantum physics might help us understand more. Quantum entanglement shows connections over big distances without regular explanations. Tests on particle-wave duality confuse our usual ideas of place and motion. Was Zeno hinting at these quantum things without knowing it? Can our studies of quantum now shine light on these old puzzles?
With all these ideas, I wonder if solving the dichotomy paradox and others shows not only things we don't know, but also new questions. If paradoxes mark our limits, can they start future scientific changes? Instead of solving them fast, can using them as signs lead to big new ideas and discoveries? What if real progress is in the discovery journey, not the solutions? Did you know that after so many years, Zeno's dichotomy paradox still makes people think about motion and time? Imagine if everything could be divided into smaller parts forever. How does that match with fast technology today? Could these old ideas really matter for today's science questions?
That's interesting, Michelle. This paradox makes us question what we think. New studies in computer science use infinite division for saving data. But even if you can divide forever, it might stop working at some point, like Zeno's idea. Can modern computer methods both agree and argue with these old ideas and show new ways for computing?
Good point, Guy. Think about how math for digital security uses ideas like infinite series. Security methods like RSA use big prime numbers, very complex. Could Zeno's paradox suggest that math might not fully explain everything in nature? Maybe this shows where math's limit is in understanding everything.
That's really interesting, Ryan. In quantum computing, the story changes more. Quantum bits or qubits can be in many states at once, which can go beyond Zeno's paradox limits. Could Zeno be showing that limits are more about how we think than real-world limits?
With these ideas, is the dichotomy paradox showing our limited understanding, or does it have clues for future things like quantum computing? Should we see Zeno's old puzzles as starting points for deeper thinking, not just hard puzzles? Could thinking about these paradoxes help us make big leaps in science? Zeno's dichotomy paradox is a curious idea. It talks about dividing the world into tiny parts. Modern tech like blockchain does the same with endless chains. Could these old puzzles show us where digital tech is going?
That's a smart point, Michelle. Blockchain's never-changing records are like Zeno's never-ending division. But tech still has problems growing. Can Zeno's ideas help us solve these issues and grow digital systems safely?
That's interesting, Guy. We see cryptographic systems, which use hard math, struggle when data grows. Maybe Zeno's idea of infinite divisions is like these problems. Can using these puzzles help us solve digital security issues?
You're right, Ryan. In quantum computing, which seems to go beyond Zeno's limits, qubits do more than classical computing. Are quantum events ready to beat old puzzles and offer new computing chances? Can looking at old challenges in new ways help us move to new technology?
With all these ideas, can the dichotomy paradox show not just our limits, but also new paths for tech like blockchain and quantum computing? Are these old puzzles obstacles or exciting entrances to new science? Can thinking about paradoxes start our next big step in tech growth?